All right, step 1, calculate the total number of valence electrons. 6 from the sulfur, 6 from each oxygen, but you got 3 of them. But then also remember that 2 minus means you have 2 extra electrons, so you want to add in 2 more electrons. So that gives you a total of 26 electrons. Just pay close attention to the charge of that ion, and you want to adjust the number of electrons accordingly. Sulfur is going to go into the center. You're going to have oxygens on around single lines, single bonds. Subtract out 2, 4, 6 electrons. So you have 20 dots to draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You got 2 left over. That means the center. 2 dots. There we go. Check the octet rule, please. Oxygens are good. Sulfur is good. This is going to have an overall charge, I believe, of -2. One last thing I do want to check, formal charge. If I was to calculate the formal charge of the sulfur, and remember formal charge is number of valence minus lines minus dots. Keep it simple. For the sulfur, sulfur has 6 valence electrons. You have 3 lines around it, and you have 2 dots. So 6 minus 3 is 3, 3 minus 3 is +1. So this sulfur has a formal charge of +1. Remember, formal charge is just this fake charge that we give our atoms to make sure that we have assigned the correct number of electrons. So 0 formal charges are the best. Sulfur here has a formal charge of +1. That means we are short an electron for sulfur, meaning we didn't assign sulfur enough electrons, meaning that it can't claim, it doesn't claim enough electrons of its own. It should claim 6, and in fact it's claiming 1, 2, 3, 4, only 5, because there's only 1 electron in each bond that belongs to sulfur. Alright, let's calculate the formal charge of the oxygens. Oxygen would be 6 valence minus 1 line for each one, and then 6 dots. That's going to be 6 minus 1 minus 6, a -1 for each oxygen. -1, -1, -1. Okay, so that's not good either, because again, we want 0 formal charge. So what can we do to make something 0? We want something to have a formal charge of 0, because we know then that's a better, more valid Lewis structure. What if, now I can't change the total number of electrons, but what if I took 2 of these electrons away from this oxygen on the left, 2 lone electrons, these dots, and turn it into a bond? So it's going to look like this. So all I'm doing is taking these 2 electrons here and turn them into a bond. Okay. When I do that, let's recalculate the formal charge for the sulfur. So sulfur now, 6 minus 1, 2, 3, 4 lines and 2 dots. Oh, look at that. Sulfur now has a formal charge of 0. The oxygen that we just incorporated into a double bond, that oxygen also has a formal charge of 0 now. You're going to find that oxygen is usually involved in 2 bonds, whether that is 1 double bond or 2 single bonds. That is the preferred way oxygen is going to bond, because that is what gives oxygen the 0 formal charge. So let's check here. Is this a better structure than what we had originally? The answer is yes. This is a better structure, because even though not all the atoms are 0 formal charge, some of them are 0 formal charge, and that's better than having no 0 formal charges. Another check to do, make sure that the most electronegative atom has the negative formal charge. if you can't avoid having negatives, and that is the case here. Oxygen is more electronegative than the sulfur, so it makes sense that these oxygens have the negative formal charge. Also check, make sure that all the formal charges added together equals the charge of the either polyatomic ion or the molecule. So 0 plus 0, -1, -1. That gives me a total of -2, which is the charge of the ion. So this right here would be the valid Lewis structure. This is the best answer. So I'm just going to clean it up a bit because things got a little messy here. So your final answer is going to want to be oxygen, double bonded to sulfur, and then those single bonds. Okay, with square brackets around because it has an overall charge of 2 minus. Perfect. Now, could I have chosen to make that double bond between the other 2 oxygens? Yes, I could have. So because I could have turned double bonds with the other oxygens, then that means I could have alternate answers. And so let's say I chose to make the double bond with the oxygen at the bottom. And your structure would look like this. -2 square brackets. That's valid. Or could I have decided to make the double bond between the oxygen on the right? Sure. So what you have here, guys, is that double bond is really distributed all the way around the sulfur. We refer to this as resonance. That double bond really is being shared between the sulfur and then all 3 of those oxygens. So this is known as resonance. And this is when you have equally valid, just as correct Lewis structures. These are all right answers. We're going to draw double arrows in between them. And if this was a test or quiz or exam, we would want to draw all valid resonance structures for full credit. And again, that double bond is really between the sulfur and all 3 of those oxygens. So the bond order here is more like a 1.3 bond order because here it is 2 bond order of 2. Here it's a bond order of 1, 1, 2 plus 1 plus 1. All being shared between 3 locations. That's going to be 4 over 3, which is a 1.33 bond order. More on that later.